Bonjour. Welcome to Wahsa Citizens Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from 10 until 11 in the morning from Monday through Thursday, and we are in our 6th week of our 9-week course. At this point, you definitely should be submitting work for marking. So a reminder that the support questions are not for marking, they are practice problems. You decide which ones and how many to do. If you're understanding a concept, it is totally okay to skip the questions and do what it is that you need to do. Spend your time wisely. You know yourself best. The answers are in the back of your book. So I really encourage you to do some of the questions and check your work. If you are feeling confident and you're getting the correct answers, then it's totally okay to move on and spend your time with something else. The key questions, the ones with the little key icon, however, are the marked questions, and these ones are the ones that you need to do all of. Don't skip any of these ones. I'm marking them all, so you need to do them all. Also, I strongly encourage you to show all of your work, your steps, and your thinking. This way, I can understand what it is that you understand. And if you are struggling with anything, then I have more information about what it is that you're struggling with and how I can help you. More information, the better. So how do you submit your work for marking? Well, there are 3 methods. The first is to scan your work and send it electronically. If you have a device, you can scan your completed work with that device. Apple devices have a Notes app, and Android devices have a Google Drive app. These both come with free scan functions that are basically just like taking pictures. Though if you need some support to figure it out, on my YouTube channel, there are tech tutorials that will walk you through step-by-step how to do this for both these apps. And again, it's fairly straightforward. If you need more support though, feel free to let me know and I'm happy to help you out. And then once you have the file, you can send it either by email to studentwork@nnec.owen.ca and CC it to me, bronwyn.slate@nnec.owen.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We're the bright red building next to the post office and have a small white mailbox next to our side entrance. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students can also fax in their work. If that is something that is a good option for you, just let us know that it's coming so that we can make sure we find it, as sometimes things get lost in the shuffle. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. So you can friend me on Facebook, subscribe to my YouTube channel, then you'll get notifications when I upload one of our radio Zoom classes. They're all recorded and I upload them shortly after broadcasting to YouTube and share them on Facebook. So it's a really easy way of finding all of our resources. Also, there are short videos that explain common errors and confusing concepts on my channel. So if you're struggling with something that isn't directly course related, but it's something that you need to work on for our course, check out there because there might be something that can help you before doing a general internet search, as that might be your best strategy. Math is a really visual subject, so I strongly encourage you to access the videos. This is really going to give you the most information and really help you understand things to the best of your ability. If you can't join me live on Zoom, if you can't watch the YouTube videos online, let me know and I'm happy to send you a copy of the recorded videos so that you still get the full experience and really set yourself up for success. If you have any questions or concerns, please reach out and contact me. My email address is bronwyn.slate@nnec.owen.ca. My Facebook is bslate-wahsa. Give me a call at the office at 807-737-1488, extension 2209, or also toll free at 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., but I teach from 9 until 11. So that is not a good time to try to get a hold of me. Okay, here is lesson 14 is what we are looking at today, trigonometry and problem solving. So our learning goals for today are that at the end of this lesson, you'll be able to identify the trigonometry strategy needed to solve real life situations. You will understand the difference between the angle of elevation and the angle of depression. So you know you've met these learning goals because you can comfortably and confidently identify which trig strategy is to use depending on the situation. And you can visualize, draw a situation, including if an angle of elevation or depression is involved. So really, we're just combining all of the lessons that we've done previously into problem solving and figuring out what tools we need to use. When we'll use this in real life? Well, we are improving our problem solving skills. This is something that is going to show up in your life no matter where you are. Problem solving is something you're going to need to be able to do. You might not necessarily need to be using trig to do it. You might be, depending on your job or life. But the skills that we work on in this course are transferable, and the ability to think critically and dive into a problem is something that you're going to be able to use wherever you are in life. But before we dive into that, let's activate our brain with some mental math. I don't believe in mad math minutes. They cause stress and anxiety and don't actually teach students any skills. So instead, we work on developing strategies that use our critical thinking skills and figuring out comfortable methods and numbers that are friendly, different things that work for different folks is how we do arithmetic. So today's question is 74 times 14. And we're going to be using the strategy of breaking factors into smaller factors. So remember that factors are two numbers that multiply to be a number. So 74 times 14 is not a friendly number to me. So instead, we're going to figure out if we break our numbers into smaller factors, maybe we can combine them in different ways that are friendly. So 74, I can see, well, half of 70 is 35 and half of 4 is 2. So half of 74 is going to be 37 times 2 is going to be 74. And then 14 is 2 times 7. And while 7, 2, and 2 are all prime numbers, so those ones can't get any smaller. And 37, I think, is also a prime number. I don't think that we can multiply that. We can cut that in any way to make it smaller, to make it more friendly. So here, we think what might be our best bet? I'm going to say that trying to do, so 74, again, we're going to just do 37 times 2, again, to get 74 again. And then if we multiply that by 2, we're going to get 148 times 7. And then 148 times 7. Well, I'm going to do this. I'm going to do partial products in my head is what could make most sense to me. So I'm going to say, well, 7 times 100 is 700 plus 7 times 40 is going to be 280 plus 7 times 8 is 56. And then I'm going to add those together. So I get 700 plus 200 is 900. 80 plus 50 is 130. So 900 plus 130 is going to be 1,030 and then 6. So breaking up in smaller factors helped us a little bit, but then we still needed to do partial products. At this point was what made it easiest for me. And you can do that. You can combine different strategies. So maybe doing partial products from the beginning could have been a better strategy for you. Maybe doubling and halving, which is kind of what we did actually, is that we basically doubled and halved and then did partial products. So the thing with this is that we can be flexible and we can do whatever makes the most sense for us in that particular situation. We don't just have to use one strategy. We can do different things depending on different things. So there we go. All right, mine's on. What prior learning do we need to know? I want to go over some angle notation just to make sure that we know some different ways to indicate angles. So I have a triangle that is labeled A, capital B, capital C on my vertices, on my corners. So I can say angle A means the angle at vertex A. This angle sign looks kind of like an L, but the vertical line is at an angle. So it's like at a 45-degree angle opposed to at a 90-degree angle. If that makes sense. Or you could also look at it, it's like a triangle with one side with the side on the right missing. So again, this is why watching the videos makes more sense to look at notation. It's hard to describe what symbols possibly look like. Interpretation can be different. But anyway, angle A just tells you, we read it as angle A, and it just tells us it's the angle at A. Second, we can say angle ABC. So that's angle starting at vertex A, traveling to B, then going from B and traveling to C. And so this is the angle at vertex B. Sometimes this is what makes most sense, is to label it according to multiple vertices. And so it is the angle is at the middle letter because we're traveling from point A to B to C, and that is the angle that's contained in that space. Or also we can label it with a letter. Most often angle notation is labeled with Greek letters. It can be indicated or labeled with letters that we usually use. That's more like what we would have with a vertex A. But if we're having the actual angle labeled inside of our triangle, often we use Greek letters. It is a mathematical tradition. I don't know where it comes from. I mean, Greek has a lot of history in defining our mathematical knowledge and education system. So anyway, probably where it comes from. So common ones are theta, which is like a 0 with a line through the center, horizontal line through the center. It's called theta. Beta, which is like a B with an extra long tail. Alpha, which is like a small A with sort of curly tails. And in your booklet, there is if you have an old booklet, I think I changed it for the newer booklets because they have a letter that I don't know what the letter is. I tried to look it up and I can't figure it out. It looks kind of like a curly J, capital J. I don't know what it is, but it is in previous versions of the booklet. So if you have an old version, you might have this curly letter, which I'm assuming is some sort of Greek letter or a poor representation of a Greek letter. Anyway, it is just representing the angle. So these are just 3 different ways that we talk about. We might be able to write how we write angles down. And so it's important to know so that you know what we're talking about. The other thing I want to talk about is parallel lines. So parallel lines are 2 lines that will never intersect because they are moving exactly the same in the exact same direction. So we indicate this with arrows on our parallel lines that are the same. Then if we have lines that cross over our parallel lines, that intersect our parallel lines, then the angles between them are the same. So here I have one line and I can look to see that the angle between our parallel line and that line is the same, both my top line and my bottom line. So it's opposite the line that crosses. A is the same angle in both of these places. The same over here where I have B as my line or my angle, you can see that these two angles B and B are the same size of the angles because they're parallel lines. If the lines are not parallel, this is not true, but if the lines are parallel, then these angles are the same. So that's just something that is really useful for the problem solving that we are doing today. Okay, so what new concepts are we looking at? Let's activate our learning. I want to go over some steps to solving problems, as this can be really overwhelming. Lots of folks find problem solving really daunting and just don't know where to start. So let's get some steps to help you get going so that you can use the tools that you have. When I'm finished this screen, I would strongly suggest you to screenshot it or save it in some way so that you have this information to refer back to. So first, when we're attacking trigonometry word problems is I would draw a diagram or even just visualize, if that is best for you, what is happening. So picture what is happening. Your diagrams, your pictures do not need to be perfect. They do not need to be exact, precise, accurate. You're just drawing a sketch, something that helps you see what is going on either on your page, or if that works best for you to just do it in your head, as that's what works for some folks, then just do it in your head. That's okay. And then 2, think about what information do you know and what information do you need to figure out, need to find, because that is also really important so that you can organize the information that you have. And then knowing what you need to find is really important, because you might need to find something before you get to the final part that what you need to find. There might be multiple steps, multiple things you need to find first. Then once you know that, then you're going to choose your strategy. So is it best to do, if you can do primary trigonometry, which is SOHCAHTOA, just using your sine, cosine, and tangent ratios, that is the easiest steps. So if you can do that, if you have a right angle triangle, if that makes sense, then use your primary trigonometry. There are less steps involved, so most likely simpler. Then you need to think about, is sine law going to work? Is the cosine law going to work for you? What is going to make more sense depending on your situation? Sine law and cosine law don't work in the same situations. So it's not like one is easier than the other. It depends on the situation, depends on what you know and what you're trying to find out. That's why you need to know that first. Then use the formulas that you need to complete your calculations. You do not need to have your formulas memorized. You need to know which ones are which, but I'm not expecting you to take up space in your brain to know that the cosine law is c squared equals a squared plus b squared minus 4, or sorry, minus 2ab times cos c. See, I don't even know. I do know it, but it's just not there on the tip of my tongue today. So it's all good. You can look them up. That is fine for your final evaluations, for your lessons. It is okay to look it up. You use your brain to apply it opposed to memorizing it. Then also, I strongly encourage you to write a sentence to make sure your answer, your number that you come up with, actually answers the question. So sometimes in your IELTS booklet, it tells you have to write a sentence. Sometimes it doesn't. I would encourage you to. I'm not going to take marks off if it doesn't require you to, but having a sentence helps you know that you've answered your question, because you put it in the context opposed to just having a random number. It also means that you can help figure out if your number makes any sense. If you get an answer of 0.225 and you were looking for the height of a building, then when you go back and read your question and try to answer a question and you're like, wait, it doesn't make any sense that this 0.225 is the height of my building if I'm talking in meters or whatever. Maybe it makes sense if I'm talking kilometers. And so then you can just make your numbers make sense and make your answer make sense. Also, there's more than one way to solve a problem. You can do what makes the most sense to you. You do not have to figure out what you think I would want you to do. You can do what makes the most sense for you. That is fine. That is the reality of problem solving, is that you do you. You're going to use the tools that make the most sense for you and the tools that you have. Unless the only caveat is that if the question asks you to use a specific strategy, because I'm trying to make sure that you understand that specific strategy, then I'm expecting you to use that strategy. But that's just to make that is within the context of a learning environment where I want you to practice different things and not just use one tool all the time. But if there's more than one way to do it and one way makes sense to you, that's totally fine if I'm not asking you to do something else that's specific. Okay, so then again, so how do you know what strategy to use? How do you know to use primary trigonometry, sine law, cosine law? We went over these in their individual lessons, but let's bring it all together. So primary trigonometry, the SOHCAHTOA, sine, cosine, tangent. So we use it when we have a right angle triangle. We have to have a right angle triangle. If we don't have a right angle triangle, these don't make any sense. So we have to have a right angle triangle. We don't have a hypotenuse, so we don't have a right angle triangle, right? So sine A is equal to your opposite over hypotenuse, cosine A is equal to your adjacent over hypotenuse, and tangent A is equal to opposite over adjacent. So again, you have to have a right angle triangle. That is key for using primary trigonometry. So with the sine law, we do it when we know either two angles and a side. Remember, this can be for any kind of triangle. So if we know two angles and a side, then we solve for any of the sides by A over sine A equals B over sine B equals C over sine C. Or when we know two sides and an angle, but the angle has to be opposite one of the known sides, then we can solve for the other opposite angle. So sine A over A equals sine B over B equals sine C over C. And that is another option. The cosine law we use when we know two sides and a contained angle. So remember, this can be any type of triangle, but we can solve for the unknown side when we have two sides that we know and the angle between those two sides, we know that angle. That's what we call the contained angle. So then we use cosine law, which is c squared equals a squared plus b squared minus 2ab cos c. Or if we know all three of our sides, then we can also use the cosine law. We can solve for any of the angles that we have. And for that, we do cos c equals a squared plus b squared minus c squared, all divided by 2ab. Remember, the cosine law is the same thing. I've just rearranged it. So you don't have to use the different ones. You can just use one and then solve for the information that you know or you don't know. The same with the sine law, but these are the ones that just help you have to do less algebra once you have input your values. Again, if you want to screenshot this shot, I would strongly encourage you so that you have a place to come back to help you remember. It's all contained here, really, hopefully accessibly. Okay, so we're going to do some practice. How do we choose the best strategy to solve each triangle? We're going to go through and we're going to figure it out. We have a triangle labeled ABC, and we know that side A is 16 feet, that side B is 14 feet, and side C is 21 feet. So that's the picture. That's all we have. There are three sides that are given. So we can use the cosine law. That's to find any of the angles. We would use cos C equals a squared plus b squared minus c squared divided by 2ab. Of course, if we were trying to find angle A or angle B, we would replace our letters appropriately. Okay, another situation, we have a right angle triangle, ABC. We know side B is 12 and side A is 8 and side C is our hypotenuse. So because we have a right angle triangle, we're going to use primary trigonometry. So we can solve for the third side of the triangle by using Pythagorean's theorem, which isn't something that we cover in this course. We use it, but it's something that you should know from previous, which is c squared equals a squared plus b squared. So we can find out what our hypotenuse is. And then we can solve for any of our angles based on our sine, cosine, and tangent ratios. And that's what we do with this situation. All right, so now we have a third triangle, ABC, where we have, it's not a right angle triangle. Angle A is 88 degrees, angle C is 58 degrees, and side A is 14.5 meters. So because we have two angles and one side are known, we're going to use the sine law. And so we can solve for the third angle by using the fact that the interior angles add up to 180 degrees, right? So we know two angles, so we can always figure out our angle or other angle. And then we can solve for any of our unknown sides based on A over sine A equals B over sine B equals C over sine C. So as you can see, sometimes you need to do more than one step to get to where you want to go, but you have the tools to do it. Okay, so now we're going to sort of sidestep and look about something slightly different than we've been learning about so far. We're going to talk about angle of elevation and then angle of depression. So then we're going to be using those strategies, but these are just sort of these give us context within our questions and help us visualize it. And they can be a little bit tricky. So basically, we look with our eyes and not with our feet. So when we're measuring angles, we also need to think about if we're looking up or if we're looking down to see an object. So here's this little image that is in your booklet, and looking at the angle of elevation first. So to figure the angle of the elevation, what we do is we think about looking straight out to the horizon, so straight out. And then if we're looking to the object and we look up, then that's the angle of elevation. So the angle here between where we look straight out to how much we have to look up to look at our object, that is the angle that we're talking about, that we call the angle of elevation. And that's all that this is talking about, but it's just part of visualizing your picture. So let's go through an example of where that might come in place. So Javier and Seema are 325 meters apart, watching a hot air balloon above them. Javier measures the angle of elevation to the balloon to be 54 degrees. Seema measures the angle of elevation to the balloon to be 38 degrees. How far is each person from the balloon to the nearest meter? So there are tools that you can actually do to use so that you can actually measure these angles. We're just going to follow with the question. We're not going to worry about the tools, but it's something that is real. You can actually measure the angles of something looking up without, it's not a protractor, but it's something similar to a protractor. So here we have Javier and Seema. I'm visualizing my picture. I know that they are 325 meters apart. And I know the angle from Javier up to the balloon is 54 degrees. And I know the angle from straight out up to the balloon for Seema is 38 degrees. So those are my two angles of elevation, right? So they're where they're looking and then up. Because I have two angles and one side that are known, we're going to use the sine law. That's so that we can figure out, because the question is asking how far each person is from the balloon. So I'm going to label my sides. I say S for Seema, J for Javier, B for balloon, and then those are my vertices, and then my corresponding sides right up across from my balloon is my small b side, across from Seema is my small s side, across from Javier is my small j side. You can use different letters, that's fine. Do what makes sense for you. But when we look at this, we don't have any matching sides and angles. So we can still use the sine law, but we just need to think first. Because first we need to figure out that third angle. We know two angles, so that means we can figure out the third angle. So the angle at the balloon at B is going to be 180, take away 54 degrees, take away 38 degrees, which is 88 degrees. So now we know all of the angles of our triangle, and we can now figure out our distances. So then our second step, we're going to look at Javier, and Javier's distance between Javier and the balloon is actually labeled S, right? Because it's across from Seema. So S over sine S equals B over sine B. And then we substitute in our values. S over sine 38 equals 325 over sine 88. So then S equals 200 meters. I'm not going through how you calculate that. This is the application lesson. So if the sine law doesn't make sense to you, go back to the sine law lesson, which I believe is lesson 12, and check that out again, or ask me questions so we can work that through. That's not our focus today. You need to know how to use the sine law to be able to apply it. So we figured out the distance from Javier to the balloon, 200 meters. So then our third step is figuring out how far Sima is, which the distance from Sima is the J distance. So J over sine J equals B over sine B. So J over sine 54 equals 325 over sine 88. So that J distance is 263 meters. So then I'm going to write a sentence to make sure that I've answered the question. Therefore, Javier is 200 meters from the hot air balloon and Sima is 263 meters from it. And I go back and I say, yep, that's what the question asks. How far is each person from the balloon to the nearest meter? Yep, that's what I did. Okay, so I really like to label the different parts that I'm doing so that I know I keep myself organized. Even if I end up writing in a way in my organization isn't actually super clear. If I've labeled like my first thing that I'm doing, the second thing I'm doing, the third thing I'm doing, here I say angle at the balloon, Javier, Sima, that just gives me a point of reference about what it is that I'm talking about. So that when I go back and look at it, I know what I'm talking about. Or when the person who's marking it goes and looks at it, they know what you're talking about. You do you, but I find organizing my stuff really useful. All right, angle of depression. So this is similar, but different. So let's see how it's different. So again, we look with our eyes and not our feet. So again, we need to think about if we're looking up or down. Angle of elevation was up, so you can imagine, hopefully, that angle of depression is down. So again, looking at this little picture of a person looking straight out at the horizon and then up or down to an object. So if we're looking at the angle of depression, we look straight out again to the horizon, straight out. And then if we look down to our object, then that angle that we took from a horizon to look down is the angle of depression. Again, this is a tool. There are tools that we can actually use to measure this angle. We're not worrying about that. At this point, we've already collected the information we're going to assume. Okay, so let's look at a situation where this might show up. From one end of a bridge above a railroad track, the angle of depression to the tracks is 37 degrees. From the point, if that point is 112 meters from the track and the bridge is 122 meters long, how far from the other end of the bridge is the track to the nearest meter? So again, these questions can be super daunting and overwhelming because it's just like, I don't even, like when I read it, I'm like, what am I talking about? This is why I think it's super, super important to visualize. And for me, that means drawing. Visualizing in my head doesn't really help me. Maybe a little bit, but with this kind of information, I'm going to get confused. So drawing it out makes the most sense. So I'm going to start again. I've read the question. I'm going to start again at the beginning and start drawing myself a picture. So from one end of a bridge above a railroad track, the angle of depression is 37 degrees. So I have a bridge and I have a railroad track. Again, if I was drawing this on a computer, these would just be straight lines. These would just be lines. It doesn't have to look pretty. So I have a point. And from that point, straight out along my bridge and then down to my railroad track is 37 degrees. Okay, so I've drawn that. Then that point I know from the railroad track is 112 meters. That's what the next sentence says. If that point is 112 meters from the track and the bridge is 122 meters long, so that's showing me the length of the bridge. That's another side. Then how far from the other end of the bridge is the track? So I see, okay, I'm looking for this distance here. As you can see, I labeled my triangle or my points as I went. So I started with my starting point was R. I just picked R. Maybe for railroad track, doesn't matter. You could pick whatever you want. Then at my track, I put T. And then because R and T are close to S, I put S as my third point, which is across from the bridge, on the bridge at the other end of the bridge. So I'm looking for the distance between S and T, that I'm trying to figure out how far that distance is. So now I can see, okay, I have a triangle. I can visualize, now that I visualize that, I can see that I have a triangle. And now I can use one of my trigonometry strategies because I have something to work with. So I labeled my sides as well, the same practices, right? So small t is across from angle t, which is 122 meters, length of the bridge. Small s is across from angle s, which is the distance from R to T, which is 112 meters. And the distance that I'm looking for is small r across from R. So I have two sides at a contained angle, the angle between those two sides, so we can use the cosine law. So the cosine law, because I'm trying to find a side, I'm going to use c squared equals a squared plus b squared minus 2ab times cos c. Of course, I don't have any of those letters, so I'm going to replace them with the letters that I do have. So r squared equals s squared plus t squared minus 2st r cos r. If you don't want to write the step, that's fine. If you don't want to write this step, that's fine. This is just making sure that you're organized and you know what it is, where you're going to be putting your variables and your unknowns. Then I'm going to be filling in the values that I have. So r squared equals 112 squared plus 122 squared minus 2 times 112 times 122 times cos 37. So r squared equals to 5,602.89. I take the square root of both those sides and I get r equals 74.9. So then again, I write a sentence to make sure that I've answered the question. Therefore, the other end of the bridge is 75 meters from the track. It said to the nearest meter, so I rounded up and I've answered the question. And there we go. So now you can do the support questions on page 35 to 36, questions 1 through 4. Give yourself patience and time. Problem solving is hard. You can do it. Just use the information that you have. Walk through those steps. Okay, let's do some practice questions today. So number 1, ZB is making a triangular wooden coffee table. The lengths of the sides are 36 inches, 18 inches, and 30 inches. What will the area of the table be? So sometimes questions don't look like anything that we've done before. And you're like, what do I do with this? So again, we're going to track it in the same way. We're going to draw ourselves a picture. So I know that I'm making a triangular wooden coffee table. So I'm going to think about it. At the top, I'm making a triangle. Does my triangle, did I measure it out perfectly? No. Do I care? No. I'm just sketching it to keep myself organized. Because it doesn't tell me that it's a right angle triangle, I'm going to assume that it's not a right angle triangle, because we only know that it is one if they tell us that it is one. Okay. But the lengths of the sides are 36 inches, 18 inches, and 30 inches. Now my triangle, the 36 and the 30 inches, they're kind of close. It's hard to know if I drew the exact right ones at the right spot. Again, it's okay. It doesn't have to be perfect exactly. This makes sense. I didn't put 18 on one of my longer sides. I put it on my short side because it's my shorter side. But again, it doesn't actually matter because I'm just sketching it to keep myself organized. So I'm asked, what will the area of my triangle be? How much space am I going to have on my table? That's what I'm being asked, which isn't something that we've been doing in this lesson or in any of our lessons. We haven't been following area. So we have to remember we're using something from the past, right? Which is the joy of math, is that we're getting building blocks to build on each other, and we can use different tools based on that. So the area of a triangle is 1/2 base times height. The trick is that when we have a triangle, whatever kind of triangle we have, the base is one of our sides and the height is a distance that is perpendicular to our base. So right now, do we have a perpendicular space to our base? No, we don't. We do not have a line that is perpendicular to any of our lines. So we don't know, so we can't just multiply 30 times 18 and divide that by 2, or 36 times 30 and divide that by 2. We need something that is perpendicular. So we are going to make that. Come on. Why won't you let me change my color? I want to change my color. Don't want to change my screen. I want to change my color. Okay, it might not let me change my color. Okay, it won't. We'll just have to go with it. So I'm going to do what we call dropping a perpendicular. I can do that from any of my vertices. Now I'm off. Okay, sorry, this I need to draw a little bit better. So this part, I do want to know that I'm going from my vertex to my other line. Sorry, for some reason I can't get to exactly where I want to be. I want to be at my point and then going down. Okay. So I'm going to label my corners, my vertices, just to keep myself organized. I'm labeling them A, B, C because they're the beginning of the alphabet. And then this other point that I dropped, I'm going to label D. So now I have two little triangles and I'm trying to find this H. That's what I need to know, right? I need to know my height so that I can multiply it by this 30 in order to figure out my area. So now I have right angle triangles. So I can look and I can say, oh, how can I figure out my right angle triangles? How can I use that information? Well, I need an angle because this whole side from B to C is 30. So I don't know only part of my sides in order to just use my two sides. I need an angle. So if I'm going to find angle B, then I could use angle B and my hypotenuse and figure out my height. So first, I'm going to figure out angle B. And because I have three sides, I'm going to use the cosine law to do that. So I'm going to use cos because I'm trying to find my angle. B is equal to a squared plus c squared minus b squared divided by 2ac finds my angle B. So then I'm going to input my information. So I'm going to go back to my triangle and just label my sides so that help myself. 30 squared plus 36 squared minus 18 squared divided by 2 times 30 times 36 is equal to, and again, this is one of those situations where there are multiple ways to do it. So you could do it slightly differently than me, and that would be fine. So I have 30 squared plus 36 squared minus 18 squared, and then all of that divided by 2 times 30 times 36, which is equal to 0. So cos B is equal to 0.86667. So angle B is equal to, so then I have to do my inverse cos function, is equal to 29.9 degrees. So we're going to say 30 degrees. So angle B is 30 degrees. So now I can use that to find my height. So I can see that my height is my opposite and C is my hypotenuse. So opposite over hypotenuse is sine. So I can see that sine B is equal to opposite over hypotenuse. This is why labeling your things can be helpful because sometimes you get squished. So sine 30 equals H over 36. So H is equal to sine 30 times 36. So put that on my calculator. And I get 18 as well. So this height is 18. It is not always going to end up being equaling the same. That's actually pretty rare. It's just how it ended up. So then to find our area, this is our third part, is our area. So we now have 1/2 times our base, which is 30. And remember, this is base, not side B, times our height, which is 18, our height that's here. And so 1/2 times 18 times 30, so it'd be great if I actually put 18 in there, is 270. So then we want to go back to see how we actually answer the question. So the area of the table is 270 square inches. We write that differently. And so yes, we have answered the question, but it took us multiple steps to get there. So sometimes it can be overwhelming because there's lots of things that you need to do. So you just gotta work your way through it. Sorry that my writing is a bit messy. Okay. Then we're getting close to be out of time, but let's just set this question up to see if we know how to answer it. Number 2, if an archer is 5.7 meters from a target and the bullseye is 50 centimeters below their eye level and straight up and down, at what angle does the archer need to shoot to get a bullseye? So again, we're just going to draw the picture and figure out what strategy we need to use. We don't have time to actually do the strategy. But we have a person. Again, you're going to see my beautiful drawings. A person who's the archer who is 5.7 meters from a target. So that's my target. So we have an archer, A, and a target, T, and that is 5.7 meters. The bullseye is 50 centimeters below their eye level and straight up and down. What angle does the archer need to shoot to get a bullseye? So if they're shooting, so we're looking at the angle of depression would be straight out, and they need to look down to hit the bullseye. And we're wondering what angle that is. And we know that this distance, so look from going straight out to down, right? 50 centimeters, 50 centimeters. So we're trying to find the angle, and we know our side. We know because it's straight up and down, we know that that means that this is 90 degrees. That's what straight up and down means. So we can use that information. So then we have 5.7 meters and 50 centimeters. We need to put these in the same units. So we're going to multiply 5.7 times 100. So to get from meters to centimeters, so that's 570 centimeters. And now we have our opposite and our adjacent to our angle. So we can use that tan A is equal to 50 centimeters over 570 centimeters. And we can figure out what tan A equals from there. And that's all that we need to do. So drawing a picture means that you go from really not necessarily knowing what it is that you're talking about to really what it is you're talking about. Again, you can see my pictures are beautiful, and I expect the same quality of art. I'm being sarcastic. You don't need to be beautiful. It's all good. This question, we don't have time to go through today. Determine the height of this cliff, where we have these 2 different triangles that explain it. I think that in previous lessons, I have been able to go through it, or there might be another video on my YouTube channel that walks through this type of question. Unfortunately, we run out of time today, but this one's a tricky one. If you need some sort of help, let me know. The key is that this triangle here, this orange triangle, is on the ground, whereas this purple triangle is up to the air. And so these triangles are perpendicular to each other, and that makes things, but they share this side here. It's a little bit tricky. Let me know if you need help with this kind of question, because there is one in your key questions. All right, let's consolidate what we learned today before signing off. So in lesson 14, we've been looking at problem solving. So we first need to identify our trigonometric strategy. So primary trigonometry using a right angle, a sine law if we have two angles in one side or two sides and one angle that is opposite the known side, we can use that. Cosine, we use either two sides and contained angle, or we have three sides. So we have various situations with various strategies that we're going to use. Our angle of elevation is when we look straight out to the horizon and up to an object, whereas angle of depression is when we look straight out at level to the horizon and then down to an object. So that's going to help you visualize and draw your situation so that you know where your angle actually is. So hopefully you can comfortably and confidently identify the strategy to use depending on your situation. That's super key. And you can visualize or draw a situation, including if it has an angle of elevation or depression, you know where that angle goes. It's tricky, it takes some practice. Practice, please. So if you have any questions, again, problem solving is really hard. So please reach out if you need some more support. I'm here to support you. Give me a call at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. Give me an email at bronwyn.slate@nnec.owen.ca or Facebook, bSlateWahsa. Remember, this lesson, as well as previous versions of this lesson, might have different information slightly. I might have done it slightly, had different amount of time. So you can check those out for previous times I've taught, are all up on YouTube at bSlateWahsa in our playlist, MBF3C. There's also archives of past terms that I've taught it, so you can check those out. It's still lesson 14. It's still be labeled lesson 14. So you can check it out there and then skip through it to what might be useful if you need something more. Reach out to me during my office hours, or we can connect outside of that. If you really need some support outside of those hours, let me know and we can make it work. Thank you so much for joining me today. I hope you have a lovely day. Miigwech.